Unit 3, Lesson 1, Part 4. In this video, we are just going to be classifying angles, not in a triangle this time, but when you have parallel lines that are intersected by a transversal. So for instance, if I have two parallel lines, remember that parallel lines are two lines that never intersect. A transversal is a line that crosses through these lines. When you have that case, you have a lot of different angles that are formed. You have this angle here, which we can call angle 1. You have this angle here, which we can call angle 2. You have this angle here, which we can call angle 3. And you have this angle here, which we can call angle 4. But you also have 4 more angles here, 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 and here. And when these lines are parallel, there are a lot of special relationships between pairs of these angles. So we're going to name them regarding their position. So let's do that. So first of all, we can have alternate interior angles. And I'm going to use this figure down here because it's a little neater than the one I drew. So alternate interior angles are two interior. So by interior, we mean between the parallel lines. So inside here. So two interior angles which lie on the interior of and are on opposite sides of a transversal. So for instance, angle B and angle E are alternate interior angles. So they're inside the parallel lines, but on opposite sides of the transversal. So B and E are alternate interior. There's also another pair, C and D. And alternate interior angles are actually equal if the lines are parallel. And by the way, we're only going to be dealing with parallel lines in this class, so all of this is going to hold true. This says they form a Z. So just to kind of show you what that Z looks like, this is what that means. So because we're looking at angle C and angle D, think of that as a Z, if that helps. So that's alternate interior angles. We also have alternate exterior angles. So alternate exterior angles are two angles that lie on the exterior of, so either up here or down here, so that's outside the parallel lines, and they're on opposite sides of the transversal. So, for instance, we have angle A, and the angle that is the alternate exterior angle would be angle G. So we have A and G because they're outside the parallel lines and on opposite sides of the transversal. So A and G are alternate exterior angles. There is another pair here, but there's no letter there, so we'll just represent alternate exterior angles with A and G. All right, moving on. We also have what we call co-interior or consecutive sorry guys, I didn't always pick that up when I hit it. co-interior or consecutive interior angles. Two angles that are on the interior of the parallel line, so they have to be inside here, but they're on the same side of the transversal. So for instance, we would have angle B and angle D. So those are co-interior or consecutive interior angles. So B and D. And we also have the pair over here, C and E. And these have a special relationship too. Oops, and I forgot to tell you that. The alternate exterior angles, back up here, A and G, those are actually equal as well. However, when you have co-interior consecutive interior angles, they're not equal, but they do add up to 180 degrees. Now in parentheses, you see that they form a C. So just to kind of represent that, it would be, I think what they're talking about is look at this and this. So there's your C, or that's a backward C. If we're looking at this side, there's your C. So you're talking about this angle and that angle. All right, so the next one we'll talk about are co-exterior angles. So you can probably guess what that is by now. They have to be outside the parallel lines, but on the same side of the transversal. So for instance, that would be A and F, because A and F are outside the parallel lines, but on the same side of the transversal. And guess what? Those add up to 180 degrees as well. The last relationship we have and angles we have to classify are called corresponding angles. Corresponding angles are angles that occupy the same relative position at each intersection where a transversal crosses two lines. So, I know that doesn't make a whole lot of sense probably, but corresponding angles may be angle A and angle D. Another set of corresponding angles would be B and F. Another pair of corresponding angles would be C and G. So they're on the same side of the transversal. One is interior, one is exterior. And those are actually equal. Now let me see if I can show you the F that they're talking about. So if you look at this, so there's the F they're talking about. They kind of form an F. All right, so those are the different relationships and what you call them. In example 3, we'll talk about how to find the measures given these relationships. I'll do that in another video.